it. Regular probability, you should know that the denominator is always going to be what number? The denominator is always going to be what number if you are talking about regular probability? The total, yes. Who said that? I don't think that sounded like... Who did? I missed that. Okay. Whoever it was, you were correct.
It was opposite.
Who? It's kind of hard to tell because you're in and out. I don't know. Okay. Put it in the chat. Send it to me in the chat because we're talking about candy bar points here, right? Gotcha. Yes, thank you. So 152. That means for all of these, I could go ahead and already put 152 for my denominator. And if it says don't reduce, then you've got half of the problem done, because usually for each of these, we will either take a half point for the top and a half point for the bottom, or sometimes a whole point for the top and a whole point for the bottom. Okay? So, regular probability, you can have all of those. Now, which ones are not regular probability? The ones with the vertical lines, because those are conditional. Those are something different, okay? We'll get back to that in just a bit. But let's take a look then. What is the probability of selecting an adult out of this entire table? Well, find your adults and tell me, what is the numerator there? Put it in the chat. Put it in the chat. You can either put it to me, or if you're feeling really confident, send it out to everybody if you want. Oh my gosh, all my other classes are like racing to put them in the chat. Come on. What? Yeah, it's 100. Do you guys know where the chat is? You can type it up in the chat, but maybe you just want to not do the chat and just shout it out. That's fine. That might shout out other people though. All right, so 100. Yes, here's adults. There is the total. Always finding the total. How about the probability of selecting a child? Probability of selecting a child out of this entire two-way table. Put it in the chat.
52.
52, that is correct. So find all the children. So that is 52 out of 152. All right. Nice job. Good work. All right. So now we're going with the columns. The probability of someone that bought something from Keystone Mall. What is that numerator? Come on, don't be shy. Donathan, Estefani, Esme, Aima, Imani, Bruno, Kimberly, Yessa, come on, Antonia.
73.
73. You got it. And the last one, what's the probability we select someone that did not buy something? 79. Any questions about any of those? All right, let's go to letter F, because that's still part of the regular probability. Letter F, the probability of an adult or that they bought something. Adult or bought something. Adult or bought something. Okay, so this is an or statement. Listen very carefully, because this is, I think, one of the hardest things to understand. And when you say or, it's like you can have this or this, and you know, you can have it all. So for an or statement, it looks like a U. I want you to think united or union. Okay, when you want to unite people, you want as many people as you can get to be united. So that means I need all adults. That means I need all who bought something at Keystone. But within those two groups, I need to subtract the ones that are adults who bought at Keystone, where there is an intersection. Adults who bought. Probably can't read that very well. So all adults would be 100. Darn it, I wanted red. 100 plus all who bought something is going to be 73. Now, I have counted this group in here twice because my line went through there twice. I can't count people twice. That's not accurate. So I need to subtract 32. And when I add those together, I get 100 plus 73 is 173 minus the 32 is 141. So the probability that we select an adult or someone who bought something is 141 out of 152. Questions on that? That's an or statement, or it looks like a U. The symbol looks like a U. It's united. As many people as we can. Letter H, on the other hand, we want those things to happen at the same time, where someone bought something and is an adult. Well, we just had that, but that was the or. This is the and, where it does happen at the same time. And with those two lines intersecting there, we said that was 32. So 32 people are adults that did buy something at the same time. So 32 out of 152. Any questions on that? All right, so let's go back to E and G. E and G. I'm going to erase this a little bit so I have a little more space. What's the probability of selecting a child given that they bought something? Okay, this is conditional. It is no longer about the entire table. Okay, it is conditional that someone bought something. So we have to find all the people that bought something. So here's the bought something. There is my total. That becomes your new denominator on the bottom. Okay. So of that 73 people who bought something, how many were children? Okay. You could go back up that line, and that is 41. So 41 out of 73. Ooh, I'm getting close to the edge there. 41 out of 73 is the correct answer for letter E. All right. And last one, letter G. Again, this is conditional. It has that vertical line. That means our denominator is not with the total of the entire table. Our denominator this time is given that they are a child. So they have to be a child. So the total for children, we said, is 52. So 52 is your new denominator. And of all those children, how many did not buy? That is your numerator. So go back in the children, and 11 did not buy anything. So that probability is 11 out of 52. Okay? Questions on that? How do you feel about working with a two-way table? Can you give me a thumbs up if you're feeling pretty good about it? Anybody feeling pretty good about this two-way table? I got no thumbs. Nobody feels good about it. Me. Who's me? Me. Yes. Who's me? S-R-S. Was that Yessa? Okay. Two. All right. Somebody said me too. 2 people out of 11. All right. Hey, we're doing well. What other questions? Hey, how about 13? You guys, 13 or another problem you actually want to go through? Mean, median, mode?
12.
12. Let's see.
Excuse me, what are we doing?
We are working on the review packet. Is this Warris? Who's speaking? I don't know who's speaking right now.
Yeah, that's me.
Okay. Yeah, we're working on the review packet. I don't know if you heard, but the test has been pushed back to Friday. And if you go on Canvas, this is the morning part. The afternoon part is that you have to do a small assignment. And today's assignment is the weekly Canvas activity that you do need to complete as part of the remote learning. And you need to go to yesterday's and do that small assignment for yesterday. All right, so what do we got time-wise? 11:06. I don't know if we'll be able to get through all of it. We'll do our best. So number 12, we have data set A and data set B. Well, let's do that in different color. Okay. We have to find the mean for both of those. Can anybody give me a one-word synonym, similar word for mean? That would be the average. How do you find the average? You need to find the total by adding all the numbers up, and then you need to divide by the number of pieces of data that you have. Okay? So if you have a handy dandy calculator for set A, that is 3 plus 9 plus 35 plus 11 plus 7 plus 7 gives me a total of 72. And there are 1, 2, 3, 4, 5, 6 pieces of data. Please be very careful when you are counting. I see a lot of mistakes or too many mistakes from people that are counting the number of pieces of data incorrectly. That answer gives me 12. So 72 is my total divided by the 6 pieces of data that I have. So my mean is 12. Okay. Median. I'm going down for that first data set. Median, one word definition for that would be middle. Median, M-E-D, middle, M-I-D, the middle. But before you find the middle, you have to put them in order from least to greatest. So starting with the smallest, 3, cross them off when you rewrite them. That way you won't be looking at those numbers again. 7, 7, 9, 11, and 35. And just write them down. It's so much easier than try to do it in your head. Okay? And then I just cross them out from the ends. Outside, 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 outside. Oh, I have 2 middle numbers. When you have 2 middle numbers, you need to add them together and divide by 2. 7 plus 9 is 16. Divided by 2 is 8. The other way to do it is if you're just looking at 7 and 9, what number is between 7 and 9? That would be 8. That's another way to do it. Mode, the one-word definition for mode is the one that occurs the most. Okay, so in this group of data, I have 3, 7, 7, 9, 11, 35. 7 occurs the most. There are 2 7s. And the range. Range. It is not actually a range where you write, this goes from 3 to 35. That is not correct. The range is a one whole number amount, which is your largest number minus your smallest number. Okay? So in this case, your largest number was 35 minus your smallest number is 3. That means your range is 32. 32. Okay? All right. Any questions about A through D on that first data set A? Is anybody still with me? Just checking. No raised hands. Okay. Thank you. Thank you. Thank you. Thank you. You don't know how much I appreciate that. All right. So data set B, I am looking for the mean, which means I need to add all these amounts together. So we got 13 plus 4 plus 4 plus 6 plus 15 is 42. So I found that total of 42, and I have 1, 2, 3, 4, 5 numbers. Divide that by the 5 numbers, 42 divided by 5. And a lot of the time, unless we make it so, we the teachers, you might not have a whole number answer. Okay, especially for, oh, that's bad, the mean. So the mean here is the average, which is 8.4. 42 divided by 5, 8.4. Okay. The median is the middle. So that is least to greatest. You have to rewrite them. 4, 4, 6, 13, and 15. Median is the middle. So the middle one here is 6. Okay. Mode, the one that happens the most. Mode, the most. I have 2 4s, so that's going to be a 4. The range is the largest number minus the smallest. My largest number is 15. My smallest number is 4. 15 minus 4 gives me 11. So the range is 11. Last question, letter E. Which data set has an outlier? Which data set has an outlier? Anybody know? Outlier kind of lies outside all the other numbers. It is either much higher or much smaller than the other numbers in the data set. In this case, I would say data set A has 35, which is much higher. So data set A. Okay. Questions on number 12. Questions on 12. All right, we got 3 minutes. Hey, we can do this last one. 2 dice are thrown at the same time. Hey, is one throw of the die going to affect the other die at all? No. So this is talking about independent events. And when you have independent events, they don't affect each other. You just multiply whatever that probability is. Okay? So what's the probability that the first die lands on a 4? Can you write that probability in the chat? Or just tell me. Well, if we have 6 sides to a die, 6 total. The probability that it lands on a 4, there's only 1 4 on a fair die, so that is 1 out of 6. What's the probability the second die lands on an even number? You still have 6 total. How many even numbers are there on a die? Well, that would be 2, 4, and 6. That is 3 out of 6, which you could simplify to 1/2. That's a 1. All right. What's the probability that the first die lands on 4 and that the second die lands on an even number? Well, since these are independent, you simply write both of those as they are and multiply. 1 out of 6 times 1 over 2. 1 times 1 is 1. 6 times 2 is 12. So that probability is 1/12. Okay? Well, that's a 5. All right, so I think that gives us just enough time for me to summarize. 1, make sure you go to today's Canvas, okay, and complete the weekly Canvas activity for 126, the week of 126, okay? That is this afternoon's part of the remote learning. If you didn't do that for yesterday, make sure you go to yesterday's date of 127/26 on Canvas, and there is remote learning for that day too. And right now, finally, the test, not the teacher, the test is scheduled for Friday. Okay? If you have any questions, you can send me a message through Canvas and I will answer you as best I can. I hope to see you all in person tomorrow. Stay warm, stay safe, stay warm, stay safe. And again, I will hope to see you tomorrow. Thanks a lot. Bye-bye.
Bye.
Bye. Thank you.